Hello and welcome to my presentation, Virus-like Particle Molecular Weight Determination via Gas Phase Electrophoresis and the comparison of obtained data points to native nanoelectrospray ionization mass spectrometry. My name is Victor Weiss from TU Wien and I'm happy to guide you through our poster. The poster, as you can see here, is divided into three parts. In the first part of the poster, you are introduced to our instrumentation. Secondly, I will present you some of our results concerning the analysis of virus-like particles with gas phase electrophoresis. And last but not least, I will compare obtained results with data points which we obtained from mass spectrometric measurements. So what about the instrument? The instrument, as you can see it here, is called Nanoelectrospray Differential Mobility Analyzer, or Nanoelectrospray Gas Phase Electrophoretic Mobility Molecular Analyzer. It separates single-charged analytes in the gas phase just according to their size. And what we obtain is a spectrum, as you can see here, for an exemplary protein in its aggregate forms, where we relate the electrophoretic mobility diameter of each species, which is the surface dry particle diameter of each species, to the corresponding particle counts on the y-axis. How is this done? This is done as it's shown here with the schematic drawing of the instrument. First, we have our analytes in a volatile electrolyte solution. We are electrospraying our analytes, and then drying of droplets occurs, and at the same time, charge equilibration occurs. Subsequently, single-charged analytes, surface dry analytes, are transferred to the second part of the instrument, which is the differential mobility analyzer. There, two forces are acting on our analytes. First, we have a high laminar sheath flow going in one direction, and secondly, we have a tunable electric field. And by variation of the field strength, only particles of a certain size are able to pass through the differential mobility analyzer, and these particles are then counted by the condensation particle counter unit, which is the detector of such an instrumentation. We took such an instrument and analyzed several VLP samples, as you can see here, for those results, starting from a cowpea mosaic virus and ending up with some very large VLPs originating from a bacteriophage. Luckily, it was also possible to obtain molecular weight values via mass spectrometric means. And we took these data points together with data from literature and combined this information in such a correlation where we plotted the electrophoretic mobility diameter of the VLPs on the x-axis and the molecular weight value, the mass spectrometric determined molecular weight value of VLPs on the y-axis. How does that help? We are now able to analyze VLPs via gas phase electrophoresis, take the surface dry particle diameter of each species, which is the electrophoretic mobility diameter of each species, to that correlation and calculate the molecular weight value of such a VLP in question with very good numbers. This we have done, for instance, here with adeno-associated virus 8 VLP. We were able to measure that by a nanoparticle via gas phase electrophoresis. We obtained its electrophoretic mobility diameter, took that value, put it to the correlation, and got its molecular weight in very good approximation to the value which we got from native nanoelectrospray ionization mass spectrometry. So to sum up, what is possible with gas phase electrophoresis? It's possible to analyze virus-like particles to obtain surface dry particle diameters, to obtain particle numbers, and last but not least, by using such a correlation, it's possible to calculate the molecular weight of VLPs with very good values. Thank you very much for your attention. In case you have any questions, please feel free to contact me.